Welcome everyone here in Hungary, in the Meandering-Sajó River, and the purpose of this video will be mainly to show some kind of best practices how to carry out UAV-based river channel monitoring and river channel surveys. I will try to summarize a few interesting things for those who are just starting to work with drones in river monitoring, river channel monitoring, especially in a geomorphological point of view. So why do we need monitor river morphological changes? These phenomena are driven by the increased changes in hydrology and even sediment load, sediment dynamics. And these processes are especially in the changing climate, in these extreme events, they are more strengthened, mainly the negative effects. And in terms of changes, we would like to understand the complexity, understand the driving factors when we are focusing on the negative issues, and also to understand the larger systems in rivers. In our chapter, we wanted to go through starting from the general survey needs and then focusing on the monitoring of horizontal and vertical morphodynamics of rivers. If we start, of course, the basic thing on what do we fly, what kind of UAS is that we produce the data collection. Of course, the most widespread types are rotary wings, but what are their characteristics in terms of river monitoring? Generally, they have limited spatial coverage due to the battery characteristics. So mainly these rotary wing, even smaller or medium-sized drones are more better for only the survey of selected subreaches or one selected band systems. But they can, the other positive part is that they can provide stationary flights. And in many kind of surveys like bathymetric surveys or even the surface velocimetry or even granulometry, we need drones stable based on the GPS correction of their position. And they can provide, in this case, a valuable information. We can even combine with these drones the camera angle. For example, in this image, which you can see is it's an oblique view SFM model of an eroding meandering riverbank in Hungary, and it's much better than the nadir view survey, and can provide valuable geometric data for future modeling of the river reach. And we can even use manual flights, because if we map the traditional photogrammetry, with these with the different settings of overlaps between the flight path, in this case we can focus on a selected part depending on changing the flights and even following the curvature of the riverbank as well. Even we can use now with these rotary wings dual gimbal models with the use of variety of cameras at the same time, even the combination of RGB imagery with multispectral imagery, which can be used for, I will talk about this later, for mapping the bathymetry, and even to use thermal cameras that can be a nice tool to reveal some ground water connections. So at the same time, we can use a nice combination of sensors. As another type, the fixed wing drones, many of you are sitting here and also online, what's the other advantage of fixed wing drones. But in terms of river monitoring, we can use them to map complex channel systems like tributaries, and even to map the whole watershed for with the purpose of to reveal the sediment connectivity, which is an important issue now in the weather extremes. However, they don't have gimbals on board in many of the models, so it can cause some stabilization issues. But with these fixed wing drones, we can usually use more, much better level of survey grade cameras. And of course, if we map several type of river environment, like in a valley setting in highlands, it can have a problem with the takeoff. The traditional fixed wings, which needed a hard landing, and also like a large path to take off, and also the complex or dense riparian vegetation. It's almost impossible to do that without any damage. So now the so-called VTOL type of fixed wing drones, as a combination of the rotor type of drones and the fixed wing drones, can take off from one point and then start flying in a fixed wing mode. If we go through to move on to the sensors, I mentioned that the traditional survey is based on RGB imagery. Now with the recent advancement, even for consumer grade drones, we can even, the new improvements on the enterprise grade drones, we can even use full frame sensors, which are much better for the optical granulometric surveys, because they can even fly from higher altitudes. We can have zoom lenses. For example, this bank erosion survey was a bit far away and can provide the necessary image resolution, the spatial resolution, and GSD for high resolution monitoring. And even they can replace terrestrial laser scanning. And that's one a direction that we also about to analyze as in a scientific research way, that how can the new RTK-based drones can replace the terrestrial laser scanning survey of collapsing riverbanks, because in many cases we are not able to go to the inside bank of a river, especially in flooding periods. But the drones, of course, are ready to do it from a bit far away. And also now the newer cameras have this mechanical shutter, which is also, it provides more reliable imagery for the bathymetric reconstruction. Multispectral images are widely used in vegetation monitoring, and of course in riverine environment, they can be a nice additional data to understand, for example, the bar dynamics on braided channel systems. And sometimes the RGB sensor cannot provide all the evident information. So it's going to be a nice additional if we combine those for the classification of the environment. And even now there's some recent advancements in some kind of multispectral sensor, like in the MicaSense. There are some new multispectral bands that can support the more better bathymetric reconstruction of shallow water, because they in other spectral bands, these sediment content works in a different way, so it can help that kind of research. Yeah, succession phases, and also for hydrologic modeling perspective, a much improved determination of Manning's roughness coefficient will be possible. Thermal infrared cameras is also a new way that we are about to investigate. That like riverbank erosion, many things are behind the process, like of course hydrological, sedimentological, and also anthropogenic variables driving the process. But some local factors, for example, groundwater income and groundwater connection, has been already revealed in many other studies, and we would like to analyze this process. They use the additional information of thermal cameras to reveal the river channel dynamics and its role in the river channel dynamics. So
one of the first steps is to provide some georeferencing for the exterior orientation for the photogrammetric survey. And for the traditional methods, we need control points like this one. And what we will do now, we have two sizes for two main purposes. We will plant now these so-called ground control points to the edge of the riverbank, and we will record and measure the high precision GNSS coordinates, and we will use these for georeferencing the photogrammetric model. And this large size is highly recommended for the higher altitude UAV flights, because these will be recorded on the aerial images of the drone.
These areas are usually far away from the villages and cities, and sometimes the signals are also not the best, so we have to rely on some post-processing georeferencing, and we need to use some base rover distribution. If we are able to measure one precise coordinates somewhere at the floodplain, then after we can broadcast that signal. So the ground controls can be a problem, especially if you would like to make a time series and some micro scale changes. We have to well co-register all the surveys. So the ground control, you have to pay attention. But now with the RTK drones, they are spreading in the last few years, and they have an advantage that, of course, to save some time and not to place and survey all the control points, because in these kind of surveys, you have to place the control points, of course, on all the riverbank edges. In this talk, I usually focus on meandering rivers as my research, and we need to place them along the riverbank edges. But if there's no a bridge or something, when you can pass the river itself, so only to do the control point surveys and placement, it can be several hours in my case. So the RTK drones are we are analyzing its limitations and advantages. And also in flooding period, when we would like to reveal the bankful characteristics, how the river channel is reacting, and also in the post-flood events, we are also not able to place the control points on the inside banks. So they are helping us in river research, these direct georeferencing surveys.
Because in this case, we can experience difficult field conditions. After a flood, we are not able to reach the inside bank of the meander. So there can be a big advantage of the RTK drones. This drone has its own RTK GPS base station. So we can set up the RTK coordinates based on the RTK GNSS high precision coordinates, and the drone itself can use these coordinates. So when it starts to capture the flight plan and capture the imagery, each single aerial image will have the high precision, like centimeter precision geolocation coordinates in the EXIF files. So theoretically, we will not need ground control points. And for example, in this case, when we would like to map rivers and the effect of floods in terms of riverbank erosion, it can save a lot of time, and it can make it possible to make accurate results, because generally for this kind of survey we would need other control points in the inside bank on the point bar surfaces, and then register all of these in the software during the photogrammetric SFM surface reconstruction. But in this case we don't need that, and in this study and in this book chapter we also try to reveal their characteristics, how accurate are these RTK drones, and what could be their advantages in the riverbank erosion surveys.
general survey needs and limitations. If we talk about the flight patterns, flight modes, in these local scale surveys, when we have to focus not on a large, like a watershed or a sub-reach scale, we sometimes use manual linear flights. But you can see on the slide, when I was surveying this bank erosion process to compare it with the laser scanner, it was the most effective. However, we still have to analyze also what kind of flight patterns are necessary for these kind of surveys. Is it enough to have a single grid or double grid, or to include oblique mode imagery to provide the most accurate bank geometry and their role in the sensitivity of modeling cases? So this is a challenge that we have to solve. Also, the stationary hovering, I already mentioned it. That's another special flight mode. And then if I talk about flight permissions, they are different country by country. And especially like in our country, in Hungary, we have quite strict regulations. And for example, I have to apply 30 days prior to the survey. How can I do post-flood reconstruction or anything real time? Maybe with special permissions, it can be 7 days, but in many cases, like a sediment deposition after extreme flood, it's not gonna work. And I also mentioned the fixed wing drones. They are usually flying at higher altitudes. Now in Hungary, we can fly at 120 meters only maximum. So now the larger scale fixed wing flights are not permitted. So we have to apply for special permission. So if you plan these kind of things, you have to really be up to date with the local regulations. And of course, rivers usually, in many cases, are situated in landscape protection zones that we also have to apply 50 days before any flights. However, they are how to say, provided for a longer period, like 1 or 2 months. So these can directly affect your surveys and survey accuracies. And of course, the extreme events. If you would like to do some real monitoring and regular flights, like each week or something, of course, these are also affected. And of course, study area conditions. What I was showing, the locations are mainly alluvial floodplains with not too much relief changes, but like mountainous regions, we have to take care about some modified flight plans to, for example, terrain following mode to provide more GSD for like sediment deposition, delineation of like alpine flows or something. And also, if the valley settings are quite narrow, we have to take care about the flights of fixed wings, because they are turning in a too wide angle and can cause unexpected situations. Canopy and vegetation cover for example, collapsing riverbanks can cause shadow effects and so on. Yeah, and also some example from my case when I started this survey on riverbank erosion. There's one site which is really loved by small birds, and they usually like these sandy riverbanks, and they are flying in an unexpected way. So I also almost crashed one time when they started to fly around, and in lower altitude flights for high or accurate riverbank surveys, they can be tricky.